In this section, we're going to talk about the state pattern. Let's say we want to build a drawing application like Photoshop. In Photoshop and in many other applications, we have a palette of tools over here, and this canvas behaves differently depending on the tool that we select. For example, if we select the selection tool, you can see the icon of the cursor changes. Now, when we click and drag, we see this dashed rectangle. Similarly, if we select the brush tool and click and drag, we see this orange line. So basically, this canvas object is responding to mouse events like mouse up and mouse down, but what it does changes depending on the currently selected tool. Let's simulate this in code. So in this project, first I'm going to add a new package, state. We're going to write all the code for this section in this package. Now here we need a new class called canvas. This class should respond to mouse events like mouse down and mouse up. So here we need two methods, public void mouse down, and I'm going to duplicate this and rename the second one to mouse up. Now in both these methods, we should do different things depending on the currently selected tool. So first we need to figure out what is the currently selected tool. We can represent that using an enum. An enum in Java is like a set of constants. Let me show you. So in this package, we add a new class. First, we change the kind from class to enum, and then call it tool type. Now here we need to define a few constants, like selection. Note that I'm using uppercase letters to name this constant. This is a convention in Java. So this is our selection tool. We also need a brush and an eraser. Now, back in our canvas class, here we need a field to store the currently selected tool. That is really easy. So private tool type current tool. We also need a getter and a setter for this field. So we put the caret over here, press Alt and Enter, and create getter and setter. Beautiful. Now in our mouse down method, we should write code like this. If current tool equals tool type dot selection. Here we should change the icon of the cursor to the selection icon. So we simulate that by printing something on the terminal. Selection icon. Now, else if current tool equals tool type dot brush, then we're going to print a different message. Brush icon. One more time. Else if current tool equals tool type dot eraser, then we're going to print eraser icon. Now, we need similar code in the mouse up method. So to save time, I'm going to copy this and then paste it over here, and then change what we print on the terminal. So the moment the user releases the mouse button, if the current tool is the selection tool, we're going to draw a dashed rectangle. So draw dashed rectangle. If the current tool is brush, we're going to draw a line. And if it's an eraser, we're going to erase something. Okay. Now we could also implement this using a switch and case statement. Now, if you have been programming for a while, you have probably seen patterns like this in your code. You have a long list of if and else or switch and case statements. And you have probably repeated these statements in different places in your code. So in this example, we have these decision-making statements in these two methods. Chances are, in a real application, in a real drawing application, we should also respond to keyboard events like key up and key down. And we probably have to repeat all this decision making inside those methods as well. So the approach that we have taken is not maintainable. The more tools we support, the longer these decision making statements are going to be, and maintaining this code is going to become really difficult. Also, here we have the lack of extensibility. It's not easy to extend this application. Let's say tomorrow we want to add a new tool for drawing a circle. We have to go to different parts of our code and make changes. For example, in our mouse down method, we should add another else if statement to see if the current tool is the circle tool. Then we change the icon to the circle icon. We have to make a similar change in the mouse up method. So extending this application is not easy. Now, what we really need here is giving the canvas the ability to behave differently based on the currently selected tool. So in both these methods, we're executing different code depending on the currently selected tool. We want this method to behave differently depending on the current tool. Earlier in the course, we talked about the 4 essential principles of object-oriented programming: encapsulation, abstraction, inheritance, and polymorphism. Which one of these principles do you think we can apply here to solve this problem? I want you to spend 10 minutes on this exercise and figure out a way to solve this problem. When you're done, come back, watch the next lesson.